The scientific method is a method that's devised to answer questions, and it's where curiosity really pays off because in order to answer questions, somebody has to be curious about something. They have to ask a question to start with. So in 1668, Francesco Redi did just that. He was one of the first to disprove spontaneous generation, and he said that maggots come from flies. That was, what he was going to question. And spontaneous generation is the idea that life can come from non-life. So life can come from a rock. And he said, no, that can't happen. Life has to come from other life. So his problem was, well, where do maggots come from? And anytime we state a problem, we're going to state it in the form of a question. And then we're going to come up with a hypothesis and we're going to have a purpose. And our purpose is really to come up with, why are we looking at this? What do we want to do? What do we want to accomplish from this experiment? And it would be, his purpose was to find out where maggots come from and disprove spontaneous generation. So his hypothesis was a statement that just maggots come from flies. We never use, I believe that something will happen as our hypothesis, but we use statements like if, and then, or, just a straight statement as this is here. His setup consisted of 3 jars. The first one was left open and it had some liver that was put in it, 2 pieces as you can see here. The second jar was covered, had the same liver in it, it had netting on it, and the third was sealed from the outside. If we look at the results, set up in a data table, and you should always have your data table done before you actually do your experiment so that you can easily collect your results. And this way you see, what it is that you are trying to collect. So in the first jar, which is open, maggots developed. The second jar, which had the netting, there were maggots that were on the netting. And then the third jar, there were no maggots. We could then also take this data and in a results section of a lab report, we could graph it. We need to know what all the variables are. So the independent variable, which will go on the x-axis, would be the cover over the jars, or the type of cover. And the independent variable is going to be what we're manipulating. So it's, he used an open jar, he used the netting, and then he used the solid cover. That would go on our x-axis. It's what we are changing. The controlled variable is what's going to be constant, what's not going to change throughout the experiment, and the treatments that are going to be the same for all setups. So here would be the type of jar, the type of meat, the amount of meat, the location that they're in, the temperature they're kept in, and the time that we allow this experiment to go on for. And the dependent variable is going to go on the y-axis, and here would be whether or not maggots appeared. You could go into, if you wanted to see how many maggots appear or, and take this experiment to the next step. And then you would also add in a discussion section, which would discuss whether or not the hypothesis was correct, which would be part of your conclusion. And then the discussion goes into, what errors could have occurred as well, or where this experiment could be, applied. So errors would not be, we didn't measure the time right. That's not a correct error. An error has to do with the design of the experiment. So that's how you would explain an error in your discussion section. And from all of this, you see the setup of the scientific method and how scientists use it to ask a question and then find an answer. And even if the answer is incorrect, it doesn't match the hypothesis, this method is used and accepted so that other scientists can see it and understand it and either agree or disagree with it, and they can perform their own experiments.